Welcome to Quiet Universe, where we dive deep into the uncharted realms of space, the mysteries lurking beneath our oceans, and the mind-bending paradoxes like time travel that keep us up at night. But before you get too comfortable in your armchair, dreaming of boldly going where no one has gone before, let's take a closer look at one of the most talked-about destinations in our cosmic neighborhood, Mars. If you were hoping for a cozy little Martian cottage with a view of Olympus Mons, you might want to reconsider. Mars has been selling itself as the next big thing in space exploration, with its rusty charm and intriguing history. But beneath that picturesque surface lies a planet that is anything but hospitable. For starters, the atmosphere is practically non-existent, made mostly of carbon dioxide. If you thought smoggy city air was bad, try taking a deep breath on Mars. You can't. And let's not forget the UV radiation that comes free with every Martian sunrise, thanks to the planet's inability to block out those harsh solar rays. It's like getting a sunburn on steroids, minus the beach. Then there's the temperature. If you thought winters on Earth were brutal, Mars takes cold to a whole new level. The average temperature hovers around minus 80 degrees Fahrenheit. And if you're brave enough to spend a winter night at the poles, it can drop to a mind-numbing minus 195 degrees Fahrenheit. Even on the equator, where the thermometer might briefly tease you with a pleasant 70 degrees, the moment the sun sets, you'll wish you packed an extra parka or 10. Now, about that water situation. Yes, Mars has water, but it's not exactly poolside material. Most of it is locked up in ice or buried deep underground. Surface water? Forget it. It's either freezing solid or evaporating into the thin air before you can even say hydration. Scientists are excited about the possibility of salty, underground reservoirs, but accessing them is about as easy as finding a needle in a Martian haystack. Gravity on Mars is a bit of a mixed bag too. At just 38% of Earth's gravity, you might feel light as a feather, but don't get too comfortable. The long-term effects of low gravity include muscle loss and bone density issues, which means you could end up as the first human balloon if you stay too long. And while floating around might sound fun, the reality is far less appealing. And who could forget the infamous Martian dust storms? These aren't your average breezy days. They can cover the entire planet, blocking out sunlight and making the surface resemble a post-apocalyptic wasteland. The fine dust particles are a respiratory nightmare and can damage everything from spacesuits to critical equipment. Mars is essentially the universe's largest dust trap, and it's not going to clean itself anytime soon. But perhaps the biggest showstopper is the radiation. With no global magnetic field to shield it, Mars is constantly bombarded with cosmic rays and solar radiation. If you're planning to set up camp on the surface, you'd better invest in some serious underground real estate, because the risk of radiation-induced health problems is no small matter. Yet, despite all these glaring challenges, Mars still manages to captivate us. The idea of exploring its ancient valleys, uncovering secrets from billions of years ago, and maybe even stumbling upon signs of life keeps our curiosity alive. But make no mistake, Mars is not rolling out the welcome mat anytime soon. It's a tough, unforgiving environment that will test our limits in ways we can only begin to imagine. That said, while Mars might one day become a new frontier for humanity, for now, it's a distant dream that requires more than just wishful thinking. It's a planet of extremes, offering both the allure of the unknown and the stark reminder that space is not just another place to visit. It's the final frontier for a reason. Thanks for joining us on Quiet Universe, where we'll continue to explore the depths of space, the oceans, and the mind-bending puzzles of reality. Stay tuned, because there's always more to discover, even if it's not always the warmest or most inviting of places. And that brings us back to Mars. This planet, with all its extremes, might seem like an impossible place to call home. The challenges are staggering, from the thin, nearly unbreathable atmosphere and bone-chilling temperatures to the relentless radiation and perilous dust storms. These obstacles make the idea of building a sustainable habitat on Mars seem far beyond our current reach. Yet, despite these overwhelming odds, the human spirit of exploration persists. With advancements in technology and a determination to push boundaries, what seems impossible today might just be possible tomorrow. Mars, with all its inhospitable traits, also holds the potential for discovery and survival if we're willing to rise to the challenge. Let's explore both sides, why it might be impossible and why, against all odds, it might still be within our grasp. The idea of humans establishing a sustainable presence on Mars is one of the most ambitious endeavors ever conceived. However, the challenges are immense, and each of them presents a near insurmountable barrier to this goal. The first and most glaring issue is Mars' lack of a breathable atmosphere. Mars' atmosphere is composed almost entirely of carbon dioxide, with less than 1% oxygen. Unlike Earth, where we take for granted the ability to breathe freely, Mars offers no such luxury. The absence of oxygen means that humans would need life support systems to survive, essentially portable ecosystems providing air, regulating temperature, and ensuring adequate pressure. But these systems would require constant maintenance and energy, which would be in limited supply. The vulnerability of these systems cannot be overstated. Even minor malfunctions could result in catastrophic failure. A tear in a suit, a malfunctioning air recycler, any of these could spell disaster, and the remoteness of Mars means help would be out of reach. The stark reality is that we are not biologically designed to survive in such an environment, and the technology required to artificially sustain human life on Mars is still in its infancy. Beyond the atmosphere, the extreme temperatures on Mars pose another significant challenge. Mars is a frozen world, yet deadly adversary on Mars. Earth's magnetic field and thick atmosphere protect us from the sun's harmful radiation, but Mars lacks both of these shields. The planet is constantly bombarded by cosmic rays and solar radiation, which pose severe health risks to humans. Prolonged exposure to these rays can increase the risk of cancer, cause damage to the nervous system, and lead to acute radiation sickness. Building habitats with adequate radiation shielding is a colossal engineering challenge. While underground bunkers could offer some protection, living underground for extended periods could have severe psychological consequences, further compounding the stress of isolation and alienation. The effects of radiation are insidious. They are not immediately apparent, but they accumulate over time, gradually eroding the health and well-being of those exposed. The constant threat of radiation would hang over any mission, a reminder that humans are, biologically, ill-suited to life on Mars. Isolation is another formidable obstacle. Mars is, at its closest, about 34 million miles from Earth, making it one of the most remote places in the solar system that humans could potentially reach. Communication with Earth would be delayed by up to 24 minutes one way, making real-time conversations impossible. This delay would make everything more difficult, from coordinating scientific experiments to managing emergencies. The psychological strain of such isolation cannot be understated. The crews would be cut off from their families, friends, and the entire human experience. The only human contact they would have would be with their fellow crew members, who would be equally stressed and isolated. The pressure to maintain group cohesion in such an environment would be immense. Any interpersonal conflicts could be magnified, as there would be no easy way to escape or take a break from the confined space. The sense of loneliness and separation from Earth would be profound, exacerbated by the knowledge that even in the event of a life-threatening emergency, help would be months away at best, if it could come at all. The absence of liquid water on Mars further complicates the prospect of sustaining human life there. While Mars does have water ice, particularly at its poles, the lack of liquid water is a significant problem. The planet's low atmospheric pressure and freezing temperatures mean that liquid water cannot exist on the surface for long. Melting ice into liquid water, which is essential for drinking, growing food, and other life-sustaining activities, would require immense energy and complex systems. Even then, the water extracted would need to be purified to make it safe for human consumption. The entire process would be labor-intensive and resource-heavy, adding yet another layer of difficulty to living on Mars. The scarcity of water also means that recycling and conservation would be critical. Every drop of water would be precious, and any waste would be a severe setback. The psychological effects of living with such scarcity would be profound, with water, something taken for granted on Earth, becoming a constant source of concern and stress. Mars' thin atmosphere and low pressure present further hazards. The atmosphere is only about 1% as dense as Earth's, offering little protection from meteorites, UV radiation, and cosmic rays. The low pressure on Mars means that without a pressurized suit or habitat, a human's blood would boil at normal body temperature. This makes the entire Martian environment hostile to human life. The need for pressurized habitats and suits adds another layer of complexity and risk to living on Mars. Every time someone steps outside, they would be at the mercy of their suit, relying on it to keep them alive in an environment that would otherwise kill them in seconds. The psychological strain of knowing that even a small puncture in a suit could be fatal would be immense. Every moment outside the safety of a habitat would be filled with tension and anxiety, knowing that the environment outside is utterly inhospitable. Mars is also infamous for its massive dust storms, which can engulf the entire planet and last for months. These storms could severely disrupt solar power generation, damage equipment, and pose serious health risks due to the abrasive and possibly toxic nature of Martian dust. The dust is pervasive, fine enough to seep into the smallest cracks and crevices, potentially damaging delicate equipment and contaminating habitats. Inhalation of Martian dust could cause respiratory problems, similar to silicosis, a condition caused by inhaling fine dust particles on Earth. The storms could also lead to prolonged periods of darkness, plunging habitats into cold and forcing reliance on limited power reserves. The unpredictability of these storms would add yet another layer of uncertainty and danger to life on Mars, making every outdoor operation a gamble. Limited resources on Mars compound these challenges. The planet lacks many of the materials that are easily accessible on Earth, such as fossil fuels and large-scale renewable resources. This means that everything needed for life, food, water, air, building materials, would have to be brought from Earth or produced using Martian resources, which is currently beyond our capability on a large scale. The reliance on Earth for supplies would be a constant burden, with every mission to Mars requiring extensive planning and resources to ensure that the necessary supplies are available. The cost of transporting these materials would be astronomical, and any failure to deliver could result in disaster. The psychological impact of living in such scarcity would be profound, with every resource carefully rationed and every use of energy or materials meticulously planned and executed. The low gravity on Mars presents another health challenge. Mars' gravity is only 38% that of Earth's, and the long-term effects of living in such low gravity are not fully understood. On Earth, astronauts in space experience muscle atrophy, bone density loss, and other health problems due to the lack of gravity. These effects could be even more pronounced on Mars, where the gravity is stronger than in space but still significantly weaker than on Earth. The long-term effects of living in low gravity could include severe health problems that could make it difficult for humans to survive on Mars. The psychological effects of low gravity could also be significant, as the body's natural rhythms and movements would be altered, leading to a constant sense of disorientation and discomfort. The technological limitations of our current systems also present a significant barrier to establishing a sustainable presence on Mars. The technology required to sustain life on Mars, including life support systems, reliable power sources, and habitat construction, is still in development and not yet proven in the harsh Martian environment. Any failure in these systems could be catastrophic, leading to loss of life. The complexity of these systems means that they would require constant maintenance and monitoring, adding to the already significant workload of living on Mars. The psychological strain of living with such uncertainty, knowing that a single malfunction could mean death, would be immense. Every day would be a struggle to survive, with the knowledge that the technology keeping you alive could fail at any moment. The high costs and limited returns of establishing a human presence on Mars make the endeavor even more daunting. The financial and logistical burden of sending humans to Mars and sustaining them there would be extraordinary, with uncertain returns. The risks and challenges involved make it one of the most ambitious and uncertain goals humanity has ever contemplated. The psychological impact of knowing that the entire mission could be cut short due to budget constraints or lack of political will would be significant. The sense of living on the edge with the constant threat of funding being pulled or resources being cut would add to the already immense stress of living on Mars. In the event of an emergency, the lack of immediate medical or technical assistance could turn minor issues into life-threatening emergencies. Mars is millions of miles away from Earth, and any help would be months away at best. The psychological impact of knowing that you are on your own, with no hope of immediate help, would be profound. Every decision would have to be made with the knowledge that there is no room for error, and the pressure to get everything right would be immense. The sense of isolation and helplessness would be overwhelming, and the stress of living with the constant threat of disaster would be immense. The potential for contaminating Mars with Earth life presents ethical dilemmas that further complicate the prospect of human settlement. The introduction of Earth organisms could irreversibly alter the Martian environment, potentially wiping out any native life forms that might exist. The question of whether it is right to alter another planet's environment, especially when we have not yet fully explored or understood it, is a significant ethical concern. The psychological impact of living with the knowledge that your presence on Mars could be causing harm to the planet would be significant. The sense of responsibility for the future of an entire planet would weigh heavily on the minds of those living on Mars, adding to the already immense stress of surviving in such a hostile environment. Terraforming Mars, altering its environment to make it more Earth-like, is a popular idea, but the technology required is far beyond our current capabilities. The process would take centuries, if not millennia, and the feasibility of such an endeavor is highly speculative. The psychological impact of living on a planet that is being gradually transformed, with the knowledge that it could take generations before any significant changes are seen, would be significant. The sense of living in a place that is not yet fully habitable, with the constant threat of failure, would add to the already immense stress of living on Mars. Finally, Mars presents many unknowns, from its geology to potential biological hazards. Unforeseen challenges could arise that we are currently unprepared to deal with, adding further risk to human missions. The psychological impact of living with the constant threat of the unknown, with the knowledge that there could be dangers lurking that we are not yet aware of, would be significant. The sense of living in a place that is not fully understood, with the constant threat of the unknown, would add to the already immense stress of living on Mars. The risks, costs, and technical difficulties involved make the idea of a sustainable human presence on Mars one of the most ambitious and uncertain goals humanity has ever contemplated. The notion of establishing a human presence on Mars, despite its daunting challenges, is not entirely out of reach. The existence of abundant water ice on Mars is one of the most promising factors that could make this vision a reality. Mars has significant deposits of water ice, particularly at its poles and beneath the surface in various regions. This ice is more than just a source of water for drinking. It is a potential lifeline for sustaining human life. Through the process of electrolysis, water can be split into oxygen and hydrogen. Oxygen, of course, is vital for breathing, while hydrogen can be used as a component of rocket fuel. This means that with the right technology, humans could generate breathable air and fuel for their return journeys directly from Martian resources. This in situ resource utilization would be a game changer, reducing the need to transport vast amounts of supplies from Earth, which is currently a significant barrier to long-term missions. Imagine the psychological relief of knowing that the essentials of life, air, water, and even fuel could be generated from the very environment that initially seemed so hostile. The presence of water ice also holds the potential for agricultural uses, where it could be melted and used to hydrate crops grown in Martian soil, further supporting the notion of self-sufficiency. The rapid pace of technological advancement offers another glimmer of hope for making a human presence on Mars possible. In recent decades, space technology has seen exponential growth, from life support systems that can sustain humans in the vacuum of space to propulsion systems that could shorten the journey to Mars. One of the most promising technological developments is in the field of 3D printing. This technology could be pivotal in constructing habitats on Mars using local materials, such as the regolith that covers the planet's surface. 3D printing would allow astronauts to create structures that are tailored to the unique environment of Mars, reducing the need to transport building materials from Earth. The ability to construct habitats, tools, and spare parts on Mars would drastically lower the cost and complexity of missions. This innovation speaks to the ingenuity and adaptability of humanity. Faced with an environment that offers little in the way of traditional resources, we find ways to use what is available. The psychological boost from being able to create and maintain one's own shelter, using the very ground beneath one's feet, would be profound. It would transform Mars from an alien, inhospitable place into a home that humans can shape to meet their needs. The concept of in situ resource utilization, ISRU, is more than just a technological possibility. It is a strategy that could underpin the entire human endeavor on Mars. Mars, though barren, is not devoid of useful materials. The planet's regolith contains various minerals that could be processed to extract essential elements like oxygen and silicon. Oxygen could be used not only for breathing, but also in the production of water through chemical reactions with hydrogen. Silicon could be used in the manufacturing of solar panels, which would be crucial for energy generation. The idea of ISRU is akin to the early pioneers who settled in remote areas on Earth, relying on the land to provide what they needed to survive. There is a profound psychological resilience in the ability to look at a seemingly barren landscape and see potential, to take what appears to be nothing and turn it into something that can sustain life. The success of ISRU would not only make missions more sustainable, but also create a sense of empowerment and independence for those living on Mars, as they would not be wholly reliant on Earth for their survival. Mars' lower gravity, while presenting some challenges, could also be an advantage in making human presence on the planet possible. The gravity on Mars is about 38% that of Earth's, which is significantly higher than the microgravity environments that astronauts experience on the International Space Station. Prolonged exposure to microgravity leads to a host of health issues, including muscle atrophy and bone density loss. But the partial gravity on Mars could help mitigate these effects. While it is not yet fully understood how the human body will adapt to Martian gravity over the long term, the fact that it is closer to Earth's gravity than that of space offers some hope that humans could maintain their physical health on Mars. The psychological aspect of this should not be underestimated. Knowing that one can walk, run, and move in a somewhat familiar way on Mars would make the planet feel less alien and more like a place where humans can truly live. The ability to engage in regular physical activity, even in lower gravity, would help maintain both physical and mental health, reducing the risks of muscle and bone degeneration, as well as the psychological strain that comes with long-term space travel. Mars is not just a potential home. It is also a treasure trove of scientific interest, which fuels the drive to explore and understand this enigmatic planet. Mars has fascinated humanity for centuries, and now, with the prospect of setting foot on its surface, we are closer than ever to unlocking its secrets. The planet's geological history offers clues to the processes that shaped not only Mars, but also the early solar system. The possibility of discovering signs of past or present life on Mars is perhaps the most tantalizing prospect of all. The idea that Mars, a planet that has captured the human imagination for so long, might once have harbored life, or might still do so, drives the scientific community to push the boundaries of what is possible. This drive is not just academic. It is a powerful motivator that could propel the development of new technologies and missions. The psychological impact of being part of such a groundbreaking mission would be immense. The sense of purpose and significance that comes from exploring a new world, from being at the forefront of human knowledge, would be a powerful counterbalance to the challenges and hardships of living on Mars. The human spirit thrives on discovery, and the potential for scientific breakthroughs on Mars could be a key factor in making a sustainable presence on the planet possible. Mars' atmosphere, though thin and composed mostly of carbon dioxide, offers some intriguing possibilities for supporting human life. Carbon dioxide can be used in the production of oxygen through processes such as electrolysis, which splits carbon dioxide into oxygen and carbon monoxide. This means that even the very air of Mars, initially so hostile, can be turned to human advantage. Additionally, the presence of carbon dioxide opens the door to the production of methane, a potential fuel source, through a process known as the Sabatier reaction. The idea of using Mars' atmosphere to produce essential life support elements and fuel is another example of how humans can adapt to and make use of the environment around them. This ability to harness the resources of Mars, to transform the planet's atmosphere into something that can support human life, is a testament to human ingenuity. The psychological effect of being able to breathe air produced from Mars' own resources, to fuel spacecraft with methane made from the planet's atmosphere, would be profound. It would reinforce the sense that Mars is not just a distant outpost, but a place where humans can truly live and thrive. Solar power is another crucial factor that could make life on Mars possible. Despite its greater distance from the Sun compared to Earth, Mars receives enough sunlight to make solar power a viable energy source. Solar panels, already a proven technology on Earth and in space, could be deployed on Mars to provide a steady supply of energy for habitats, life support systems, and other equipment. Energy storage systems, such as batteries, would be essential to store energy during the day for use during the long Martian nights. The reliability of solar power, combined with the ability to generate it from the sun's rays, offers a sustainable solution to one of the biggest challenges of living on Mars. The psychological boost from having a reliable source of power, one that can be replenished daily, would be significant. It would reduce the stress associated with energy scarcity and allow those living on Mars to focus on other challenges and opportunities. The sight of solar panels gleaming under the Martian sky would be a reminder of human resilience and the ability to harness natural forces to support life in even the most extreme environments. Human adaptability is one of the most powerful reasons why establishing a presence on Mars might be possible. Throughout history, humans have demonstrated a remarkable ability to adapt to new and challenging environments, from the frozen tundras of the Arctic to the sweltering deserts of Africa. The human body and mind are capable of extraordinary feats of adaptation, and with the right preparation, training, and technology, there is no reason to believe that humans could not adapt to the conditions on Mars. This adaptability is not just physical, but psychological as well. The human spirit is resilient, capable of overcoming fear, isolation, and adversity. The challenges of living on Mars would be immense, but the drive to explore, to push the boundaries of what is possible, is deeply embedded in human nature. The psychological impact of overcoming these challenges, of turning Mars from a hostile world into a place where humans can live and thrive, would be profound. It would be a testament to human ingenuity, resilience, and the unyielding desire to explore the unknown. The potential for agriculture on Mars is another factor that could make a human presence possible. While the Martian soil is not immediately suitable for growing crops, experiments have shown that it might be possible to grow food in Martian soil with the addition of nutrients and water. The ability to grow food on Mars would be a significant step towards self-sufficiency, reducing the need to transport food from Earth and providing a sustainable source of nourishment for those living on Mars. The psychological impact of being able to cultivate food on Mars would be profound. It would provide a sense of normalcy, of connection to Earth, and of control over one's environment. The sight of green plants growing in the red soil of Mars would be a powerful symbol of life and hope, a reminder that even in the most barren environments, life can take root and flourish. The ability to grow food would also provide a sense of purpose and responsibility, as those living on Mars would be actively contributing to their own survival and well-being. International collaboration and investment are crucial factors that could make human missions to Mars possible. The scale of the challenge is such that no single country or organization could tackle it alone. Collaboration between countries and private companies could pool resources, knowledge, and expertise, accelerating the timeline for human settlement on Mars. The psychological impact of being part of a global effort to explore and settle a new world would be significant. It would create a sense of unity and shared purpose, transcending national boundaries and bringing humanity together in a common cause. The challenges of living on Mars would be immense, but the sense of working together to overcome them, of being part of something greater than oneself, would be a powerful motivator. The drive to explore and settle Mars is not just about technology and resources. It is about the human spirit, about the desire to explore, to push the boundaries of what is possible, and to reach for the stars. Mars' day length, or sol, is another factor that could make life on the red planet more manageable. A sol is approximately 24.6 hours, which is very close to an Earth day. This similarity would help humans maintain a natural circadian rhythm, which is crucial for physical and mental health. The ability to maintain a regular sleep-wake cycle, to experience day and night in a pattern similar to that of Earth, would make the adjustment to life on Mars easier. The psychological impact of maintaining a familiar rhythm would be significant, reducing the stress and disorientation that can come from living in an environment with a vastly different day length. The similarity in day length would make Mars feel less alien, more like a place where humans can live and work comfortably. It would be one less challenge to overcome, one more factor that makes Mars a place where humans can truly thrive. The drive to explore is deeply embedded in human nature, and it is this drive that could ultimately make human settlement on Mars possible. Throughout history, humans have ventured into the unknown, driven by curiosity, the desire for knowledge, and the pursuit of new opportunities. The challenge of Mars, much like the challenges of past exploration endeavors, could be met by the determination, creativity, and resilience of humanity. The psychological impact of being part of such a monumental endeavor would be profound. It would create a sense of purpose and significance, a feeling of being part of something greater than oneself. The drive to explore, to push the boundaries of what is possible, is what has propelled humanity forward throughout history, and it is this same drive that could make human settlement on Mars a reality. The challenges are immense, but the rewards, scientific discovery, the expansion of human knowledge, the possibility of a new home for humanity, are equally great. The journey to Mars is not just a technological challenge. It is a test of the human spirit, a testament to our ability to dream, to innovate, and to explore the unknown. As we stand on the precipice of interplanetary exploration, Mars offers a tantalizing mix of challenges and possibilities. The red planet, with its inhospitable conditions and yet intriguing potential, forces us to confront the limits of our technology, our endurance, and our imagination. But it also invites us to dream, to innovate, and to push beyond the boundaries of what we know. Whether Mars becomes a second home for humanity or remains a distant, mysterious neighbor, one thing is certain. The journey there will teach us as much about ourselves as it will about the universe. Thank you for joining me on this exploration of Mars potential. If you found this journey through the cosmos as fascinating as I did, don't forget to like this video and subscribe to Quiet Universe for more deep dives into the mysteries of our universe. Your support helps keep the exploration alive, and there's so much more to discover together. Until next time,